Hello. Welcome to Purushotam Academy. Today we are going to know computer architecture. In computer engineering, computer architecture is a set of rules and methods that describe the functionality, organization, and implementation of computer systems. Some definitions of architecture define it as describing the capabilities and programming model of a computer but not a particular implementation. In other definitions, computer architecture involves instruction set architecture design, microarchitecture design, logic design, and implementation. The discipline of computer architecture has three main subcategories. Instruction set architecture, ISA, defines the machine code that a processor reads and acts upon, as well as the word size, memory address modes, processor registers, and data type. Microarchitecture, also known as computer organization, this describes how a particular processor will implement the ISA. The size of a computer's CPU cache, for instance, is an issue that generally has nothing to do with the ISA. Systems design includes all of the other hardware components within a computing system, such as data processing other than the CPU, for example, direct memory access, virtualization, and multiprocessing. Computer architecture is concerned with balancing the performance, efficiency, cost, and reliability of a computer system. The case of instruction set architecture can be used to illustrate the balance of these competing factors. More complex instruction sets enable programmers to write more space-efficient programs, since a single instruction can encode some higher-level abstraction, such as the x86 loop instruction. However, longer and more complex instructions take longer for the processor to decode and can be more costly to implement effectively. The increased complexity from a large instruction set also creates more room for unreliability when instructions interact in unexpected ways. The implementation involves integrated circuit design, packaging, power, and cooling. Optimization of the design requires familiarity with compilers, operating systems to logic design, and packaging. Increases in clock frequency have grown more slowly over the past few years, compared to power reduction improvements. This has been driven by the end of Moore's law and demand for a longer battery life and reductions in size for mobile technology. This change in focus from higher clock rates to power consumption and miniaturization can be shown by the significant reductions in power consumption, as much as 50%, that were reported by Nptel in their release of the Haswell microarchitecture, where they dropped their power consumption benchmark from 30-40 watts down to 10-20 watts. Comparing this to the processing speed increase of 3 GHz to 4 GHz, 2002 to 2006, it can be seen that the focus in research and development are shifting away from clock frequency and moving towards consuming less power and taking up less space. Thanks for watching the video. Please subscribe to our channel for more updates.